Hello, we're going to be doing a demo of lab number 1, and it's where we're going to interface the software with the myDAQ hardware. First thing that we want to do is to make sure that you're in the block diagram. The block diagram is indicated up here, and it's the one that doesn't have the crosshatch screen. So to start with, come over to the top left, right-click on the mouse, go to Structures, and we're going to create a while loop. We need to have enough space to kind of enclose our entire program. And at the bottom right, you're going to want to click on this point right here and say create control, and the control will be a stop. So just leave that way. And then over on the right, there will be a point that you can attach to called loop iteration. You right click on it and say create indicator. And we can just call this loop iteration. So double click on that, type in loop iteration. And notice how this wire doesn't have a connection to this input. Just right click on the wire and say clean up wire, and it shows how it's properly connected now. Now let's create a digital input so that we can see what's happening in our logic inputs. And I'm going to start off by placing 2 round LEDs on the screen. And it could be square, just about anything you want. And I'm going to give them a name because I know this one is going to represent the start push button, which is on bit 5. I'm going to write that down too. Very useful to put which bit you're working with. And if you need to troubleshoot, you'll have that information. So I'll label this stop, and it's on bit 4. Okay, now that we have that information, we can go to our block diagram. So up here, it's Window, Show Block Diagram, or Control E. The next step is I'm going to add a DAQ Assist. So under Measurement I/O, click on myDAQ MX, that stands for Measurement Explorer, and then DAQ Assist. I'll place it just to the left because it's going to be getting the data from the real world. You want to select Acquire, and then Digital Input, Line Input, and we're actually working with the myDAQ, and I know it's connected to bits 4 and 5. So I'm just going to hit the Control key, select 4 and 5, and then finish. That opens up this panel, and the first thing I want to do is rename these bits, and you can see that bit 4 is the first bit in the list in that order. So bit 4 is going to be the stop, so I'm going to rename this to stop. Okay, and then rename this to start. Delete that one. Okay, so we have start and stop. Now, notice this little bit of an issue here, and I think it's a glitch in the software. So I'm just going to click OK. And when you reopen that, it does display properly. That's one error I have noticed. You have to wait for it to build that VI. So double click on this. Okay, and now it does have start and stop. Now I can actually test out the hardware by clicking on Run. And you'll notice that the stop button is already pressed. If I'm pressing it on the proto board, that's working, and that's working. So it tells me that everything is okay. Once you verify everything is okay, click OK. Now, what I need to do is wire the outputs of the DAQ Assistant to the inputs of the 2 bits. To complete my wiring, I have to make a connection between these 2 bits and the DAQ Assistant. Now the data coming out of the DAQ Assistant is an array, so I need to convert the array to individual bits. And I'm going to use something called index array. So right click on the block diagram, go to array, find index array, place it here, and right now it only has 1 output element. So if you want to have 2, you got to drag this down. And the top one is going to be the top from the DAQ Assistant, the bottom is going to be there. So I believe I had it set up, and we can double check here the order, because it does matter. And if I go to details, the first one is the stop connected to line 4. I'm just going to do OK here. And stop, let's make it to the top bit. So I'll just reverse that. Come down here. Okay. If you don't do that, you'll have the stop connected to start and start connected to stop. So it'll be the reverse order. So I want to connect the array. The array is a different colored line, so it's a little thicker. If I go to the elements, I can come over here and connect it to that coercion point, and then to that. You don't really need to hook up these indexes. I believe they just stay at their default. So that would be the first and second. Now let's actually test this out. So we'll go to the front panel and click on Run, and the stop button is functioning correctly, and it's on bit 4, and the start is on bit 5. So everything works okay. So that's the end of this part. Now we're going to create the DAQ Assist for a digital out. So to control the digital out, we need to add a couple of switches. So I'm going to go to the Boolean. I'm just going to use these toggle switches. And this one's going to connect to the green LED or bit 0. So I'm going to type in green and bit 0 so I have a good reference. And to make things a little bit easier, you can just copy it. That's your choice, but we have red, and this is going to be called bit 1, and delete everything that comes after that. So we have the green and red bit that we're going to control. So I already have my front panel controls. So now I'm going to go to my block diagram. And since these are going to be controlling something, the hardware, I want them to be on the left. And now I'm going to add a DAQ Assist. So that's under Measurement IO, DAQ MX, DAQ Assist. And we need a little bit of space to add a build array. So this time we're going to generate a signal. It's going to be a digital output, line output, because it's not a group of bits. Make sure you're going to the myDAQ. And while holding the control key, select line 0 and line 1. And then finish. Now we want to change the names here. So line 0, I know that in my hardware, line 0 is the green LED. So I'm going to name it green bit 0. And the other one is the red. Rename that. The red is going to bit 1. There we go. So now that we have all that, click, well, you might want to bring this back just to check everything. Red bit 1, green bit 0. And you want to have sample on demand selected here. And then once we've got that, click OK. Now, as I said, the inputs and the outputs to the DAQ Assist are arrays. So you have to have something that converts the single bits to an array. So there is a function called build array. You'll find that function under array, and it's called build array, which is right here. And it's just a single bit right now, so you have to drag down so you have 2 bits. We're going to tie this one into here, and this one into here, and the output over to here. Okay, everything seems to be okay, but let me just step back because I forgot to do one step that can be useful. So while you're in this point here, if you want to verify that everything seems to work okay, you can click on that Run button, and it gives you 2 little icons here. One that I'm just verifying the red LED turns on, and it did. I looked at my hardware, and this one turns on the green. So it kind of tells me that everything is okay up to that point. And then you select OK. And now we can actually run this. So front panel, and if I want to test this, don't click on the run continuously. We already have this in a loop, so you want to click on just the run button. And then this switch should control the green LED on bit 0 and the red LED on bit 1. And I looked at my hardware and it seems to work okay. I think we're done this part. All right, in this next part, we're going to configure the analog inputs so we can measure the voltages from the photocell and the 10K variable resistor. So the first thing I want to do is on my front panel, create 2 numeric indicators. So here's one of them, and I'm going to call the first one channel 0 10K variable, because that's where that's connected to. And then I'm going to create a second one, numeric indicator, and I'm going to call this one channel 1. Let's use the same formatting. And it's the photocell, which is also a light dependent resistor. So I'll put LDR here so it's clear. So channel 0 is that one, channel 1 is that one. So we've got that set up. Now we go to the block diagram. You can see we've got our variables here. And since we're going to be reading information, sorry, that's a mistake. Since we're going to be reading information, we want to have this on the right-hand side and the DAQ Assist on the left-hand side. So measurement IO, DAQ Assist, click on that. It'll open up, and we want to acquire signals or read them. And we're going to read analog inputs this time. We're going to select voltage and use the control key to select 2 channels. Finish. Now here are some things that we do have to set up. So we'll just say differential. I'll talk about that at another time. And we want the maximum to be 5 volts and the minimum to be 0 volts. So we'll change those values. Make sure you have 1 sample on demand set here. And we'll go to details. The first channel, channel 0, is the 10K variable. So I'll change the name here. It's useful when you troubleshoot. So 10K variable. And maybe we can put channel 0. That doesn't hurt. And the other channel is going to be, I'm going to rename that. The other channel is going to be the photocell on channel 1. And as I said, it's also called a light dependent resistor. Now we'll want to test these 2. So you click on the run button. Okay, and I have my variable resistor on channel 1, and you can see there's a value up there. And when I turn the variable resistor clockwise, the maximum voltage I get is about 4.6 volts. You might want to record that or note it. And if I go all the way counterclockwise, you want this to be the counterclockwise direction. It's making its way down to 0. Okay, and you notice it's flashing between milli and micro, so a very small value. Whereas the photocell on channel 1 is reading about 2.6 volts. And the way I've wired it, when I cover the photocell, it should drop. So that's about 750 milli or 0.7 volts. So everything seems to be working correctly. So now I can stop this and click OK. And now I want to connect the DAQ Assist to the variable and the photocell indicators. Now to do this, you actually have to put something called from dynamic data, because when you click on this, you're actually outputting dynamic data. And dynamic data is kind of a blue, thicker blue line, and the data contains a lot of information. It contains channel, the values, the date, the time, data type. So there's a lot of information in there. But we're going to break it down in just to its scalar data. Okay, no direction, just a value. So to do that, you right click, and you're going to come down to Express and Signal Manipulation, and select from dynamic data type, okay, because it's coming from the data type. And here you've got to do a couple of things. You have to select single scalar, and we're going to connect to channel 0, so you want to make channel 0 selected here. And that's about all you have to do. So single scalar, channel 0, select OK. And we do the same thing here. Express, signal manipulation from dynamic, and you put that here. And this time though, there is a difference. We're going to select channel 1. Okay, and then connect this to that, this to that, and then connect one side to the data and the other side to the same point. Okay, it's the convert from dynamic data type that will actually break it down into individual bits. Now, if you want to see those bits, you can actually do create constant, and it'll show you which bit is being controlled. Okay, so everything seems to be okay there. Let's test it out in the front panel. Okay, so those are my two values. Now you'll notice the top one is not wide enough to see the whole thing. So I'm going to stop it and make it a little bit wider in that box. Okay, so it's showing a very low value, 0.002 volts. So I'm going to increase my variable resistor. And you can see it's going up to 1 volt, 2 volts, and so on. We're going to modify the number of bits you see a little bit later on. Channel 1 is my photocell, and it drops down to about 0.7 when I cover it, and higher when it's not uncovered. So everything seems to be working correctly. We're going to move on to the next section. All right, in this part of the demo, we're going to be adding the analog output. So the first thing I want to do is have two controls, one for channel 0 and one for channel 1, where we can measure the voltage, probably using a digital multimeter. So click on numeric control, and I'm going to call this one channel 0. Let's call it DAQ. Okay, channel 0 DAQ. And then if I want, like I said, you can hit the control key and copy that. You just have to make some changes to the text. And we're going to get rid of that too, because it doesn't want to give it the same name, so it just adds a little suffix to it. So now that we have that, we can move to the block diagram. You can see here's our two variables. And we want these to be on the left side of the DAQ Assist, because we're going to be sending a value to the DAQ Assist. So I go to measurement. This time it's on the left, and we connect to DAQ Assist. Put it over here, but we want some space in between because we're going to be adding something called merge. This time though, we're generating a signal. It's an analog output. It's going to be voltage. And we're going to connect to two channels. So you hit the control key to select two, and then finish. Now we have to make a few changes here. The screen looks quite a bit different than the others, but we'll go to details, and our channel 0, we're just going to call this, rename channel 0 out, channel 0 DAQ out. I'm going to say OK, and this is going to be channel 1 DAQ out. Delete that. Oops. Channel 1 DAQ out. And we'll use the same formatting. And then that's fine. So channel 0 of the DAQ is on analog output 0. This is on analog output 1. The one thing we do want to change up here, I think before we do that, we have to come down to generation mode and switch to one sample on demand, and then these screens do change. Okay, but I think we have it all set up to test out before we actually run it. So I'm going to do run, and I'm going to connect, I'm going to send out 2.2 voltage on channel 0. And I'm going to select 3.3 volts on channel 1. After clicking the run button, I'm going to use a meter just to verify that I have 2.2 volts on channel 0 and 3.3 volts on channel 1, and they both measure correctly. So that tells me that everything is okay. Once you've done that, click the OK button. All right. Now, the next thing we have to do is connect those two bits to the DAQ Assistant. So it now does have a channel for that. And the input data is dynamic data type. So we have to have something that allows us to connect these two bits to that dynamic data type. And one of the ways to do that is to go to the ExpressVI's signal manipulation, and we're going to do something called merge signals. I'm going to put this in the center, and you can see that these types here are combined signal, and what it's going to do is going to send whatever I connect to the top input to channel 0, whatever I connect to the bottom input to channel 1. So the order does matter. Now, if you want to show what these icons are on the screen, you can go to Visible and Label, and it tells you that it's merged signal. Up here, you can do the same thing, Visible Items, Visible Items, and Caption. It says Convert Dynamic Data Type. Okay, we can do the same thing up here. We can see everything. Just put Label. But sometimes this is helpful when you want to create or change something. So now let's go back to the front panel. So Window, Front Panel. And we're actually going to test everything. And I'm going to move this over. And you can see we've got a loop iteration here. And let's just test this out. So the first thing I want to test is the voltage to my DAQ. So I'm just going to type in 2.2 for 0 and 3.3. These are just arbitrary numbers, but they're two different arbitrary numbers just to verify each channel. And now I'm going to measure the voltage. The voltage seems to be okay. I'm going to press the start and the stop. They seem to work. I'm going to press the green, and that goes off. Press the red, and that goes off. So I think everything seems to be okay. This is my variable. It's going up as I turn clockwise. This is my photocell. It goes down. So everything is working okay. So if you want to stop the program, you can just press stop here. That's the better way to stop it. And then if you want to rerun it, just press run. Over here, press stop. So everything is working as expected. In the next few sections, we're going to add some improvements to what we have. All right, in this part of the demo, we're going to modify some of the icons and the graphics on the page to just improve their visual appearance. So for example, this toggle switch, if I right-click on it and go to Properties, oops, I'm in the wrong place here, just right-click, Properties, and here you can see that I can change the color. So I'm going to change the on color to a bright green. We'll use this one, and the off color to a very dim green. Maybe we'll use this one, so that when we run it, as an example, it's a dim green when it's low, it's a brighter green when it's on. Same thing for the red. Just right click, go to Properties, and Colors on. I'm going to change it to red, and when it's off, just a very, see if we can go over here and just make it a very light color. So now when I run it, we're going between two states. Now we're going to do the same thing for the two LEDs. So the start bit, I actually want to be green and gray. So we're going to stop first, and then right click on it, go to Properties, and I actually want it to be a bright green when it's on, but just to have a better indication when it's off, we're going to make it go gray. Same thing here. Well, actually, let's make it light green and bright green. I don't know if there is a brighter green. Maybe we'll go with this one, and for off, a very light green. So we can go to here. If you go up towards the top, you're just reducing that brightness. So very light green there. And for the red, same sort of thing. Select it, properties, and we want it to be red when it's on, just a very light red when it's off. So let's come over to this red and just go up a bit. Okay, there we go. So now when we run it, when I press the start button, it goes green. When I press the stop button, it's not red. It's a lighter color. And if I want to make it a little bit bigger, I can do that. Change the shape, for example. I can do that and run it. Okay, we have those two buttons. Or I think I can change the shape as well. So I changed the shape to a square, and I made it a little bit bigger, so that improves the graphical representation. I can also change it into a button. Okay, there are different things that I can do, but I'll leave it that way for now. All right, in this demo, one of the things that you might want to do, or that you should do when you're working with numerical values, is set the precision. So you can see this number right now has a whole bunch of digits after the number 2, when really the only ones that are useful is maybe a couple of digits of precision. So to change that, you want to stop the program, right-click, and go to Display Format. And you want to, it might already be set to automatic formatting, but change it to floating point and change the number of digits to 2 significant digits, change that to digits of precision, and then hide trailing zeros. So floating point, 2 digits, precision, and turn this hide trailing zero, turn it off. And now when you run the program, all you see is a couple of digits after the digit. And so when you adjust the variable resistor, there's not a whole bunch of digits after that. And the square becomes a little bit too large, so you can make it a little bit smaller. If we run it again, there we go. And we're actually going to attach a graph to that in the next thing that we do. In this section of the demo, we're going to work with a waveform chart. So to begin with, you have to right-click on the front panel, click on Waveform Chart, place it somewhere on the page, and then we have to go to the block diagram so that we can actually hook it up. Okay. If you see broken wires like this, the quickest way to get rid of them is press the Control key and the letter B on the keyboard, so Control B. Okay, that gets rid of broken wires. So we want to connect this to the 10K variable. It's now connected. Go to Window and Show Panel and run. Ooh, notice this odd waveform that you get. The voltage is jumping up and down quite a bit. And that's because we have the chart set to auto scale. We don't want to use auto scale. So to turn it off, we're going to right click over here, right click on the chart, go to Properties, and then go to Scales. What's a little bit tricky here is there's 2 adjustments for scales. We can do the X and the Y axis. So make sure you select the proper axis. We want to select the Y. Okay, and notice the Y auto scale is turned on. So turn it off and let's run it again. Okay, it's turned off, but the scale right now is between 2.4 something, and there's 2 ways of changing it. We could, when it's running, actually just type in 5 for the maximum and 0 for the minimum. And now it's at the appropriate scale. The other way that you can do it, I think you have to be online for this, or sorry, off. I'm going to stop the program, right click on the display, go to Properties and Scales, X-axis. Well, that's not the one we want, so it's Y-axis. and you can see you can type it in right here. Okay? Avoid using auto scale. So that's okay. Now the next thing we want to do is set the number of points that are read into the chart, and right now it's set for 100, and we can leave it at 100, so that's fine for this example. It seems to do what we want to do. The other thing is we can change the name here to match up with channel 0 10K variable, so they both have the same title names. And now the next thing I want to show you is if you want to change the background color and the line color, we can do that up here. So I'm gonna, well, I'll close this off so you'll see where to find it. We go to View, and then Tools Palette, and then this green thing means automatic. And these are different tools. That's the operate, so when you want to move a button up and down. This is the position size, letters. This is for connecting a wire. And this is the scroll window. So use some of these. And this is to probe data. We'll look at that a little bit different time. Quite often though, I will turn it off, especially when I'm doing what I want to do here. And I select the set color for the background. And I'm going to make the background white. Now whatever I touch, it will turn to white. Okay. Once you've done that, turn the automatic feature off. You can close this, but I think the line was white, so we want to change that to black. So go to Properties and Plots, and you want to change the line color to, let's make it blue. Okay, so I think we're okay with that, and you can see that it's blue. Okay, fine, and that works perfectly well. Okay. One other step though, because every time we start the program, you'll notice it's going from 700 to 800. I might want it to start at 0 all the time, and it's not doing that right now. So I'm going to stop this. I'm going to right click anywhere on the waveform chart. I'm going to do a create something called a property node. Property nodes are very, very useful for graphics capabilities in LabVIEW, and I'll show you more about it. I'm going to go to History Data, and I'm going to put this property node here, and right now you can see where it says History, and it's pointing out to the right. So what I want to do is right-click the mouse and change to right. So I'm going to click on Change to Right. Now that little coercion is over here. I'm going to right-click on that, create a constant. And that constant is going to fill it with zeros at the starting point. Now the only thing is I did it from within, but you want to make sure that's outside of the loop. So I need to move both of these things outside the loop. I wish I had done that before, but there we go. It's outside the loop. So try to create it outside the loop. Now when you run this and go to the front panel, every time that I start it, it starts off at 0. That makes it kind of useful. It'll run past 0 once you get beyond that. Now you can put a scroll bar. I think there is. Yes, you can put a scroll bar. You right click, Visible Items, X scroll bar. And now when you run it, once it fills past the 100, the scroll bar will come into play. And there you go. So if you want to look back in time, you can move the scroll bar. I think you can even stop it. So let's press stop, and we can go back in time. Now let's start this again, and we'll actually make some changes so we can see what happened in the past. Okay, so we're going way down low here, and then we're going to go up a lot. But now if I stop, and I want to see what did happen in the past, I can move that scroll bar from the beginning to the end. So that's very useful. I think I've covered everything I wanted to cover there. Okay, that's great.